Hi everyone. How do we get an equation for a circle in the xy plane with center h comma k, not necessarily the origin, and radius r? We want all points x comma y that have distance r away from this center h comma k. So what do we want here? We want all points x comma y that satisfy the following equation in principle, where the distance between x comma y and h comma k is equal to r, the radius. I want all points x comma y that satisfy this property. All points whose distance from this center point will be r. Well, what is the distance between x, y, and hk? That's given by the distance formula. The square root of x minus h all squared plus the quantity y minus k, the difference in the y coordinates, all squared. Make sure this all goes into the radical. We need that to equal r. We know that the sum of squares in here is non-negative. Let's square both sides and we get, well, it's right here. Remove the radical on the left. The square of x minus h plus the square of y minus k equals the square of r. This is the standard form for an equation of a circle whose center is at h comma k and whose radius is r. I say standard form because, well, here's another equation for the circle, but this is our favorite equation for that circle. All right, so for example, again, we want the circle to consist of all points x comma y whose square distance from hk is r squared. The distance has to be r, the squared distance has to be r squared. Example, find an equation of the circle, the standard form for an equation of the circle in the xy plane with center at -2 comma 1. So this here is going to be h comma k, and radius 3. That's going to be our value for r. Let's assume that distances are measured in meters, but that won't come up in our equation. Well, let's apply this formula. And we get, right, by following the formula, we get x minus -2 all squared. Remember, you need grouping symbols around a negative number to make sure here that the minus signs here don't come close to each other. These are sort of like very competitive alpha males or something. You can't have them right next to each other. You have to separate them out using grouping symbols. All right, so we have the square of x minus -2, right, plus the square of y minus 1 equals the square of 3. This is in standard form, but we usually write x minus -2 as x plus 2. So the square of x plus 2 plus the square of y minus 1 equals 9. So either of these would serve as standard form for the equation of the desired circle. Now, if I were to give you either of these equations, and if I were to quickly ask you, what are the center and the radius? Well, for the radius, make sure you remember that the radius is not 9 here. 9 is r squared. R itself is just 3. So do remember that. R itself is just 3, or 3 meters. To read off the center here, here's the trick. The center is -2 comma 1. The center makes the left-hand side equal to 0. So when you want to find the center of this circle, you're asking yourself, what values for x and y will make the left side equal to 0? The idea is that the center has a square distance of 0 from itself. X equals -2, y equals 1. That makes the left side equal to 0. Remember, folks, the center of a circle is not itself a point on the circle. So the center will make the left-hand side equal to 0, not 9, or r squared. The center of a circle is not technically a point on the circle, but we often like to indicate the center when we're drawing a circle. Okay, so let's compare the two circles we've just seen. This is called a translation. When we go from this equation in black to this equation in red, we're translating the corresponding graph. We're translating the circle. We're talking about translations in general in chapter 1. And yes, it will involve, in general, substituting x with x plus 2 if you want to move the shape to the left by 2 units. And we're going to substitute y with y minus 1 if you want to translate up by 1 unit. Those general principles will apply in chapter 1 for more general graphs. So here is an early example of a translation. Next up, how do we make an equation like this look something like this? Put it in standard form. Next time.